almost there, almost there. Right. Right, there we go. That's Manny, that's usually one we're waiting on. Maybe there somewhere. Okay, so we're waiting on a couple more to join in. Are there any questions you want to go through before we move on to the next section, which will be ground running? Have you got any questions about yesterday you want to go through? Does everybody know everything?
Why do we need to measure torque?
We need to measure torque because if we don't, we can stress the engine to the point of it will disintegrate or break up. Too much torque means too much power, and engines can only go to so much torque, especially for turboprops and piston engines. If you provide too much torque, then things will start breaking. So we keep the torque within a certain level. If torque is a twisting action, so with reference to turbo propellers and turboprops, piston engines, if they're spinning too quick, the propeller's trying to spin off the shaft, and that's holding the engine, then potentially it could snap off. Okay, so we need to keep a measurement on torque. Likewise, we go back to the cars and motorbikes. If you have too much torque, you'll rip your wheel off, break drive shafts and things like that as well. So you have to make the engine suitable to maintain that torque. Okay. Torque is good. The more torque is better, providing the engine and the propeller can handle the torque. That's the main thing. And just normal day-to-day, if you're working fitting bolts to aircraft, if you apply too much torque, you'll break a bolt. And likewise, if you don't apply enough torque, it won't be tight enough. So torque is a twisting moment. So again, with reference to engines, too much torque can possibly cause some damage. That's the main thing. So we have to keep it within the set limits that aircraft and that engine is designed for. Anything else?
No, warm up done. We can continue.
Very good. Okay, right. We'll get on. Just looking for Manny. He's not in yet. Okay, we'll start anyway. We'll catch up. Okay, so we'll get a good bit done today. And as I say, we'll definitely have everything finished by lunchtime tomorrow, I'd say at the latest. So we'll have a lot of recap of book 4, and we'll go back away, book 3, book 2, book 1, and same again Friday with a nice big long question section for the whole lot. All right, so today let's get on with it. We are going on to ground running. If I get my page up, there we go. All right. So yeah, we're going to look at running engines. That photograph that was taken from the Falkland Islands when I was down there a couple of times. I used to spend 4 months down in the Falkland Islands. That's the jets we used to work on, and that's just doing a ground run, full performance run. So you can see the reheat at the back, and we will have a little chat about reheat, or afterburner, as Americans like to call it. But there is times that we're going to have to carry out ground runs, just to periodically check the engine's working good. Or there might be a fault diagnostic, or indeed you might have changed something. Okay, or you want to even test a different system out, hydraulics and stuff. So there's going to be lots of opportunities to do. So why the car do it? Yeah, after installation, after the Replacement of a unit that affects operation or performance of the engine. So that could be a fuel control unit. It could be the FADEC itself. If you change anything that controls the engine, affects the power or performance of the engine, and you've changed it, and then you have to do a ground run. If you've adjusted any parameters on the engine, there was a spec where we had to what was called derate the engine. As that aircraft I just saw before, as it was getting older, we had to reduce the settings a little bit. We got information from Rolls-Royce. They gave us some information, calculations, and we had to derate it. So not give it quite as much power as it had before, just to help it last a little bit longer. It's a very, very small amount. The pilots wouldn't know any difference, but when we set the engine up and did the calculations and adjusted the equivalent of a FADEC, it just helped the engine last a little bit longer. Again, there might be a fault. The pilot might have landed and said he had a maybe vibration in the cockpit. Okay, I can do a vibration run, or it wasn't working right. Maybe the governor wasn't working. You know, it may be hunting, lots of things. So again, as required, and also at specific times. Been called to do for adjustments, checking the aircraft system. So yeah, you might have changed maybe even the wing, a rudder, a fin, or whatever. You might be putting hydraulic systems on. So part of it might just be actually to provide hydraulic power. Normally, though, you would actually apply an external hydraulic rig, but if that's not available, then yes, you could start an engine up, and that provides the hydraulic power to the gearbox. Check engine performance at set page. Yeah, a health check. Basically, that's what we're doing, a health check. Make sure it is doing what it should be doing against the book. You'll have the data in the logbook, and you'll check it. You'll take a note of your figures on your gauges, and you'll put it in the computer, and it'll come up with basically yes or no, greens or reds, as we call it. And if it needs adjusted, you need to adjust it. Or likewise, if it's way out, then we'd have to possibly change the engine. It's maybe not quite as good as it. If we can't fix it, then we might have to reject the engine. So to do that, you're going to need some information to run the engine. And normally get in contact with air traffic control, and they'll give you things like outside air temperature, the pressure of the day, humidity of the day, any potential weather forecast that could affect your ground running. Yeah, it might be a cool day in the morning, but then getting snow in the afternoon, you know, so you've got to try and, if you're going to be doing a long ground run, so because sometimes the ground runs can take quite a while, or it could just be a very quick ground run. And it depends if you're doing full performance runs, a little leak check, or whatever it is, okay? But again, you should really get all the information required for that. And likewise, if you're fitting a brand new engine, you probably need fire cover. So you probably need the fire engines to come around as a precautionary measure, especially on a brand new engine. So yeah, pressure altitude, that can be maintained by setting the altimeter at standard 1013 millibars, which is sea level, and reading the pressure altitude from the main scale. Okay. Or again, you can go to or get in contact with air traffic control, and they can give you the information as well. The air temperature, now it's the shade air temperature, because where you're ground running might be in an area which is covered in shade, but the outside temperature might be slightly different. So the temperature where you are doing the ground run should be measured with a mercury thermometer immediately before any checks which require correction of temperature. Now, some of the airports that we worked in, very, very open, even where the ground running was, the temperature is pretty much the same anywhere around the airfield. So we would just get in touch with air traffic control. Safety precautions, lots of them. Okay, FOD, that's the worst enemy of any aircraft. That engine is a big hoover. It will suck anything off the ground and possibly damage it. So again, you'll prep the aircraft, you'll chalk the aircraft, etc. Make sure it's ready for start, and you also check the groundwork. Make sure there's nothing loose on the ground that can potentially be dragged into the engine. Obviously, you should have ground running guards fitted to the intakes to prevent that, but always be very careful. Some of the big aircraft, they don't put them on for idle runs. They'll just do a quick start. But again, if you're doing idle runs, potential that some small debris could indeed be sucked into the engine. Wind direction, very important. Always try and head the aircraft into wind. Don't do it with the wind behind you, because that'll try and spin the engine the wrong way. And also the wind conditions. Yes, wind direction is very important, but how windy is it? Is it too windy to start an engine run? Because aircraft we might be working on, like my ones on military, we have to open the cockpit. If it's too windy to open the cockpit, it's probably too windy to do an engine run. And you've got to think about fumes coming out of the engines, potentially damaging towards APU intakes, which we'll come on to in a minute, and for noise as well, because wind can carry noise. Danger personnel, yeah, those engines are very dangerous. You do want to get sucked inside one. Anybody else that's working around the vicinity of the aircraft, if you're doing full performance runs, you've got the efflux of the gas coming at the back of the engine at a very high rate of knots. So again, that could potentially blow things over, and anybody behind it. So again, you have a safety area to make sure nobody gets hurt. A lot of commercial ones have designated ground run areas where they'll actually deflect the exhaust gas up the way from barriers, and it helps to reduce the noise in the surrounding area as well. So you've got your jet in position. You'll have put locked in position, chocks and all that. So you need to remove all the blanks, ensuring intakes and exhausts are free from loose items. Fit intake guards, so these usually coloured red, little debris guards like a filter, so it allows the air to come in but not any bits of debris. And likewise, remember, be very careful if you've got a suspect icing conditions in a cold sort of humid conditions, or even very hot humid conditions. You're doing field performance runs, be very careful and watch out for ice build up on the intake guards themselves, and it will build up very, very quickly within seconds. Okay, so you are allowed to ground run, but be very careful if it is a possibility of icing conditions. If required, fit necessary test equipment. Yes, you might have to plug some test equipment in at the same time, especially for the FADEC type scenarios where you'll be adjusting the computer of the engine. It could be vibration equipment, it could be any sort of equipment. There's lots of different equipment you might need to fit as you're doing an engine run. And then mentioned icing conditions, yeah, check the IGVs are clear of ice and the LP compressor is free to rotate. It might be very, very cold in the morning, you've towed the aircraft to condition, but inside it could be very, very icy already. Okay, so make sure you have free rotation. So just get in hand and just gently spin the LP compressor. Usually they're fine for them. It's tough to be very, very extreme conditions. Check your oil contents. Yeah, make sure you've got oil in the engine, as well as engine oil. Make sure you've got fuel. Check your CSDU, your IDG, your generators, your gearboxes, your engine. Okay, and top up in accordance with your maintenance manual. Now, if it's landed, it should have been topped up after it's landed. You shouldn't really be filling them up when it's cold, because as mentioned before, if you fill up to maximum when it's cold, when that oil heats up, it can potentially siphon out the drain, okay, and actually empty the system. So never fill a cold engine up to maximum, always in accordance with the manual. Ensure all access panels and counts are secure, yeah. Vibration, more so with certainly turboprop aircraft, with a big air going over the back, that can blow a lot of panels off. And likewise, jet engines, if there's any panels at the back of the aircraft, that can potentially be blown off. Obviously a bit dangerous and a bit embarrassing at the same time. Typical ground running area, again, it will depend on the airfield you're working on. These are designated ground running, so you park the aircraft tail in here. So when the jet gas comes out, it gets blown back and then it actually goes up the way. Okay, so that helps keep efflux from the gas hitting the runway, and also it puts the noise up the way. Okay, so it helps environmentally more friendly as well. So there you go. There's a jet in the area, designated area. Okay, so obviously these lines will be marked out specifically for the aircraft. You can sort of size of markings, and you'll have chocks. And sometimes you'll have, if you're doing full performance runs, where you've got engines flat out, you'll have not just normal chocks, you'll have maybe metallic chocks which bolt into the actual concrete. We still have those again for the military aircraft, which are far stronger than standard rubber chocks. Because there has been occasions where it is possible to what we call jump the chocks. If you've got normal chocks in there and you go full power and bring it back to idle and put the full power very quickly, the aircraft can actually jump over the chalk. That has happened before. So these special chocks, the big metal ones, big pins, they're there to help, and they double chalk the aircraft as well. If you're doing full performance on engines, you tend to do one at a time. You wouldn't do all at the same time because that'd be too much power. So you'd be testing every engine independently. And you can have two engines running, all engines running, but you would only put one engine up to full power at any one time. Danger zones, yeah, you should know your danger zones of that specific aircraft. And if in doubt, it might even tell you, like we've got a line here, okay, it tells you distance. You should be a minimum of 4.2 meters away from the intake on that side, and a minimum of 14 feet away from the engine on this side. Otherwise, it's a very low engine, and again, there's potential you could get dragged into the aircraft, and that's the end of that. All right, stand clear of hazard area while engine's running. Yeah, anytime the engine's running, you should never be at the front of the engine, obviously, for obvious reasons. Sometimes so, you might have a door open to do a leak check because you've done your static leak check, and now you might be doing your dynamic leak check. Right. So again, if you do have to go to an engine when the engine's running, always at idle, always make sure you have communications with the controller in the cockpit, and make sure they've got what's called hands off. So they're not touching anything. You'll get indication either visually and obviously in communications. Usual indication is we put our hands on the head to say hands off. Okay. If you lose communications. Once you've got confirmation of that, then yes, you can approach the engine in a safe manner, maybe suspect a leak, or you want to adjust something as well. Then once you've done your job, you come back out, give indication to the person in the cockpit, you're clear, they can then do the next check as required. The main thing is make sure you have communications at all times. Now, different aircraft will have different power supplies, power available, thrust available. This one we've got an example of a 20-foot radius, okay, around the engines there, the front of engines, but we've got back to about 250 feet, okay. And as it goes back, it spreads out. It will diminish through distance. I've seen myself, and I've been called out to an aircraft with a problem in the aircraft. We ran out to the back, and there was a jet was starting up. It was just a way to taxi out, so it revved up just as we ran past it at the back, and we got blown away a little bit. Okay, they were fine though. Does happen. Be very careful. Reverse thrust. Well, you got opposite of forward thrust. Yeah, you have to be careful. Is that coming? No. There we go. The usual suspects. Okay, so yeah, you've got to be very careful around the aircraft. There might be a lot of aircraft. If you've got heated defenders on, you might not necessarily hear the aircraft that's running. You walk past the back of the jet and you get tumbled over by the efflux. Okay, so just be very careful. Always aware, especially in busy airports, it's very easy not to hear an aircraft. Sounds a daft thing, but when you've got ear defenders on, you're concentrating on the job, you turn around, the next thing an aircraft just run over you. Okay, so be very careful when it's a busy environment. That's when things go wrong. Why do we use concrete runways? Well, it saves embarrassment and things like this happening. This is a real case. You've got monoblock type assembly, and they've parked the aircraft on it. Some simple little chocks, wooden chocks, and well, monoblock is loose fitting stones covered with sand underneath. High powered engine, what's going to win? Yeah, the engine's going to win. So it started to blow all the monoblocks away. So you can see the guys are taking a photograph of the damage. Yeah, not very clever. Okay. Always make sure you ground run in a concrete running environment. You are allowed to do it on tarmac on small power settings only, if that is all that's available, but definitely not on monoblock, loose interconnecting stones. All right, you can see there some of the dust, some of the bits of stone. You can see, you can actually see some on top of the tailplane. All right, yeah, not very clever. There's some closer damage. That's a lot of money's worth of damage there for a bit of non-common sense. Okay, unavoidable, well, avoidable damage in this case. Should not have happened. So prepare, check, and then once you're happy, make sure you're okay to go. I mentioned wind direction. Okay, in the maintenance manual for each one, we'll describe the first sequence of engine starting. Again, watch out for all the good stuff. The wind direction, if you've got wind direction come at a slight angle, we've got an example here. Remember, you've got the APU, special commercial aircraft, at the back of the aircraft. If you've got this engine here running, well, the jet efflux can maybe be blown into the APU air inlet. Well, that's very hot, oily sort of gas. Well, if that's going into air into the APU, that could potentially damage the APU. All right, and it could potentially cause it to surge, and that can blow up. So again, be very careful on the direction. Again, you should, as best as possible, don't get me wrong, when you locate your aircraft on a ground running pan, the wind direction might be perfect initially, but by the time you've got your equipment set up, everything else set up, the wind direction might have changed. So again, be very careful. And if it's a very windy environment, again, you might have to cancel the ground run until better conditions do arise. Okay. Right. What else? All right. Again, the ground running, only running kept to a minimum unless you're doing full performance runs. Thrust reverse levers, again, everything should be operated slowly. Communications. If the conditions are not ideal, but you can ground them, again, just do it for a minimum amount of times. Always obtain accurate readings when checking fuel systems, power settings. Again, make sure any load scenarios are off for fuel power checks like anti-icing, electrical parts you don't need parts. Any sudden increases in AGT, so you are like a chameleon, you're watching everything in the cockpit and you're constantly scanning the cockpit, all the gauges as you're doing the fuel performance runs. 9 times out of 10, it's going to be fine. You're going to do the fuel runs, you'll be checking this, you'll be checking that, everything's okay. It's that one time it goes wrong, you've got to be able to react. And you might not get something go wrong for a long, long time. So you do a ground run, ground run, ground run, ground run, so on and so on. And it's that day, you've just been a little bit, not lazy, but just a bit complacent. And that's when it catches you out. You should always be ready for something going wrong with an engine, because it goes wrong very, very quickly. All right. But again, you should see, you'll recognize telltale indications. You'll have done lots of hours on a simulator before you actually go and do a real ground run. All right. So again, you'll be checking your figures, checking against the engine's logbook and seeing how much of a discrepancy is, and you might be able to tweak the engine on the deck. You can actually things like potentiometers and just calibrate the engine to get it a bit more healthy again if required. Or it could be fine. All right. You might not have to do anything at all. Full performance check, put it into the book, check it on the computer. It's good to go. And special commercial aircraft, they're not under a lot of pressure like military aircraft, like the ones I worked on. They get thrown about all over the place, so they're under a lot more stress. Commercial aircraft tend to last a lot longer. Okay, good maintenance keeps a quality aircraft. Typical engine start panels, again, they will vary from aircraft to aircraft. We've got, here's your start one, you've got a crank. So again, remember what a crank was? It was turning the engine over on the starter with no fuel or ignition, or we could have fuel, because if we put the throttle open, we can have fuel, but again, there would definitely be no ignition. Crank an engine, why would you crank an engine? For leak checks, compressor washings, anything as required to do so. It might have changed the starter, simple as that. In this case, got a twin engine here, on and off, fire faults and all that good stuff. And yeah, we've got engine starts on this panel as well. Okay, all depends on the type of aircraft you're working on. So typical checklist. Well, first thing we're going to do is we're going to start the engine. Once we've all the safety precautions been done, everybody's got communications. If we've got fire engine, fire bottles required, external ones, especially if it's a new engine. Okay, everybody should know exactly what their role is for that ground run. From the operator, it could be two in the cockpit. Yeah, big aircraft could be two in the cockpit. Your supervisor outside, or could you supervise inside? Can't have a supervisor inside because he can't see what's going on outside. So you usually have a supervisor outside. Safety person, as many as you feel required. Okay, depends on availability, but don't run below the required minimum amount. So a supervisor, safety person, fire bottles. Okay, so you might have 3 or 4, maybe even more people, depending on what you're actually doing. So once you're happy with all that, okay, start the engine. And then you allow the engine to reach self-sustain and idle, and record all instrument readings. Make sure all the lights that should be out are out, and all the lights that should be on are not on. And you'll be, as you start an engine, you'll be checking for low oil pressure light. Again, this will happen very, very quickly. Right, who's others coming now? Okay. Check generator cooling air system. Yeah, we don't get the gens getting too hot, so we'll be checking on those as well. Again, it will be the running. This is a general oversight. It's not specific to any aircraft. It's just a general oversight in case you don't get too worried about it. Open throttle and check that exhaust gas pressure, your P7, is within limits. Okay, so check your pressure gauge, your EPR gauge, and that sort of thing. And check other limitations are not exceeded. So as you open the throttle, nice and smooth progression up to maximum, and you get your full performance figure. Let it settle at maximum for a few seconds. Don't just take a reading straight away, because especially with free turbines, it take a bit of time to spool up, as they call it. Check how long it takes to go from idle to maximum. Some of them do what's called a slam check, where you open the throttle very quickly, and the engine will spool up to speed within a certain amount of time. If it doesn't do it with a certain amount of time, if it's too quick, it could surge, and likewise, if it's too slow, it could stall. Okay. And likewise, when you're at maximum, you come back to idle, and you're also checking the deceleration time. So accel checks, decel checks. When you've done that, you might have to do it a few times, depending. Select the reverse thrust lever, control lever disconnected, and check maximum reverse and normal reverse limitation. Now this part is only checking the actual lever connections, that they are moving within the correct amount, not the actual function of the thrust reverse. And so I've got it, I might put that in red actually. Control lever disconnected. You're just checking the physical movement. Now, it seems a bit weird. This is one example we've got. You probably find you would check that before you start the engine, actually physically moving the throttle back and forward. That'll be part of your pre-start checks, is checking the full range of movement of your throttles. Do they go forward? Do they go back? Do they select the thrust reverse? Okay, mechanically, even before you start the engine. Right? So that's a bit of a strange one. Car out vibration survey. Yeah, you have done that. After your slam checks, you'll do a nice slow, we call it what's called, it's not in the books, it's called a waterfall check. You'll put the throttle up very, very slowly. It'll take a few minutes. And as you do that, you'll get the vibration trace we looked at yesterday. And then you can analyze the vibration traces. And likewise, if you feel vibration, you can pinpoint the RPM of what's happening. Don't hold it in there, because if you're getting vibration at that point, then it's probably best to come back to idle. If you hold it in that vibration a long time, that's going to amplify that vibration. So you can either, through experience, depending on the nature of the vibrations, actually throttle past it. If it goes away, that's a better sign that this only specific part of that engine is vibrating. If it gets worse, then there's something really serious is going on. So that would be a case of bringing it back to idle. But if you find a little bit of vibration and you check it by going past it and the throttle and goes away, then we know that something with the engine's going on. But if it is vibrating all the time, then something serious is going wrong. Yeah. Do your anti-icing checking system. Yeah, on and off. Again, depending on the aircraft, you might obviously check your thrust at the same time, because it might drop in thrust by your anti-icing being activated. If you've got a water injection system, which we'll look at later on this chapter for power augmentation, recheck idling speed. Is the RPM sitting where it should be? Is it too high? Is it too low? And then once you're happy with all those bits and pieces, stop the engine and you check what's called the rundown time. How long it takes for the engine, once you've shut off the fuel, for it to physically stop. If you shut the fuel off and the engine goes like that, stops really quick, well, that's not right. You should hear a nice, gentle stop, and take quite a few seconds to stop down. Okay. Open the cowlings, the doors, accessible doors. That'll let the aircraft cool down a little bit, the engine cool down, and you're also checking for leaks, especially if it's been a new engine. Now, what I would say about that is if you've got a new engine, you're not going to do full power checks straight away. You probably start the engine up, the doors open, and check for dynamic leaks. If there's any leaks at idle, it's only going to get worse at full power. Again, you'll follow your running checks before you do that. If there's no leaks at idle, yeah, you shut the doors again and then continue with the normal full power checks and so on and so on. It's always good practice. Open doors and just have a final check of the engine once it's shut down. So we'll have the thrust reverser disconnected initially. Now we reconnect the thrust reverser control lever and we restart the engine to function test the thrust reverser. at idle RPM only. Okay. Function over temperature control system as well. So if over temps, it should shut down. And I've got a note at the bottom there. If the engine has an inoperative lubrication system, windmilling must be restricted to 6 hours. Okay, there's no limitation for an engine with an inoperative lubrication system. That's depending if it's a very windy environment. Okay, and you've got engine shut down and the wind is moving or windmilling the compressors. Okay, what you do, you fit blanks. The blanks will then stop the engine from windmilling, because if it's got a problem with the lubrication system, that engine's spinning round. Then if especially the HP comp is spinning, that's spinning the HP shaft, that's spinning the gearbox, that's going to spin the oil pumps, you know, and that's going to cause problems. So, and likewise when that's in the air, if you've got a windmilling engine there, that can cause problems as well. Okay, let's see what anything else I can say about that one. That's pretty much it for there. Right, okie doke. FADEC engines, right, this is where we get back onto it. So the FADEC engines, a few more checks, a bit more in depth, as I say. Okay, mod engines, again, we'll have your FADEC ones. Very stringent procedures for starting engines, and first instructions will always be precaution with safety, safety, safety. Can never have enough safety, all right? So not always in place to protect the operator, but it's more to protect the actual components of the engine. So, big one here is, if it is recommended that an engine operates at or near idle for a minimum of 2 minutes before you go to high power settings. Okay, so you start the engine as you've done before, and to be honest, you do this with any engine, you probably leave it for 2 to 3 minutes anyway, but a minimum of 2 minutes. Let the engine get the temperature, let it settle down, and you've done all your checks. By the time you've done your checks, it's probably 2 minutes anyway. Once you're happy, then you can do your next power checks. You must move the throttle control lever slowly, carefully, and smoothly when possible. So no rapid, jerky movements, nice, progressive, smooth operation of the throttle, and it should operate as required. Okay, it's going to sync a bit for some reason. I'll change that again. Anything else on there? Again, in the books, again, it's more specific to FADEC. You're looking out for things like, you know, anything that's not normal, all smooth, progressive. I'll just read out some of the examples in the book. Again, you'll see them in your book as well. There it says warnings, warnings, warnings. Classically, there it says do not stop the engine by hand. For reasons obviously being quite obvious, you know. Some people will spin the compressor blades for checking them. Always spin them slowly. If you spin them very fast and try and stop by hand, guess what happens to these things? Okay, get damaged. Do not allow an engine to run up with thrust reverse coils doors open. Common sense there prevails as well. Okay, so don't let it do that. Operation must not exceed minimum idle when personnel are in the area, like we said before. Passenger doors, because the commercial aircraft, your passenger doors, depends where the engines are fitted on your aircraft. If your passenger doors open, again, fumes get in there and also potentially rip the doors off. Again, if you don't obey those options, then certainly things will go wrong. On the book, it does say ground run with no obstacle near than 50 meters, under 64. Watch out for wind limits and operation of icing conditions. Again, just be very careful. Okay, not too bad. Main one you want to maybe highlight in the books, I'm sure it's the same in the old book compared to the new book. There's one of the warnings for FADEC is, again, similar to the APU, if the engine, the actual aircraft engine shuts down automatically, well, if they uncommanded, not by you, then make sure you also switch the start switch to off, because there's a chance it might try and initiate a restart on its own. And the last thing you want to happen is when you go to check the engine, you've not switched it off, and the engine starts to try and start itself again. I'll say a bit embarrassing, so don't want that. Okay, so like the APU, switch it off before you go and check anything. All right. I don't know why my PowerPoint's a bit funny there. All right, anything else I want to do? We've done that. Check it out. Yeah. Okay. No, that's fine. Don't know why my PowerPoint's going better. Let's see where we are. Emergency procedures, that should be just about here. Basically, in the new book, there's lots of limitations. That one said about the 6 hours one for windmilling limitations, again on the ground, but more so for in the air. If you shut an engine down when you're flying, again, if it's a non-working lubrication system for some reason, it's best just to get the aircraft down before, because if you leave it running for more than 6 hours, that can do a lot more damage to the engine. So just make a note of that point there. Sync. Okay. Again, so I've got a little read through the books. It should be pretty much the same in, I think it's book 5. I've got book 4 here, but it'll be book 5 in your old books about the limitations and all that. More specific to FADEC. All right. A lot of it, to be honest, is common sense. Shut the doors. Make sure people are aware. You know, safety, safety, safety. There's never anything too much there. Right, so let's get up to where I want to be. We've got auto starts, all that good stuff. Other notes I might say is, again, 2 minutes, before you get high power. We've done that one. A lot of the notes are just a run through, so don't get too worried about those ones. What we'll go through at the moment now is emergency procedures. So once you've done all your ground run, once you're happy that everything is run correctly and you're going to shut the engine down, that's fine. But what happens if you get a fire? Okay, so in the event of a fire warning, the engine should be immediately shut down and appropriate fire drill carried out, which again, you'll all have been trained for. If the engine is in a cowled position, in other words, the doors, the sea ducts are around it, you have to check that as well. So the aircraft fire extinguishing system can be used. So if you're doing a ground run and the doors are all closed, and you get a fire capture in your cockpit, you are allowed to set the fire bottles off. But in reality, where possible, again, it depends on the size of the aircraft and accessibility. Your safety person outside, there will be access panels in and around about the engine, or indeed to the front of the engine. You can use an external fire extinguisher, because if you use the aircraft one, then again, that's potentially a lot more work. Where always possible, try and put the fire out where it is on the ground. All right. I've got down there, if unkilled condition, do not use aircraft system, must not be used. I don't know what's slipped out there. Extinction will disperse to atmosphere and not be affected. In other words, if you have the doors open and you blow the extinction on there, well, it's just going to go all over the place. It's going to be specified to the engine. Okay, so as long as the doors are shut, you could potentially put the fire extinguisher down the intake, but again, that could cause engine damage to the engine. But the engine's probably already damaged anyway because it is on fire. It all depends on type and accessibility. Only tackle fires if you feel confident, and obviously you're authorised and have been trained to do so. Metal can be replaced, but you cannot be replaced. Okay, so just be very careful. We've got instances where it might just be an overheat, like the LP cooling light has come on the cockpit, you've got an overheat, okay? So we have to deal with that. So in the event of an indication from either of the lights, the engine should be shut down and a close watch made of the fire warning light. So we've got an overheat condition. Again, I've had that a couple of times myself. We shut the engine down, but because it's already hot, there's a chance we could get spontaneous ignition of something. So you keep an indication, keep somebody in a fire bottle just in case. And obviously, if you've got an overheat condition, you probably have the fire section out, and they'll be there with their heat sensor gun, checking the temperature, like I had one of those occasions as well. The fire extinguishing system should not be used. You've got an overheat, which means it's not a fire. So don't use the extinguisher. Observe it in case things get too hot, where the heat is radiated out, it potentially might be melting something, then cause a fire, that's different. But certainly do not use the extinguishing system on an overheat condition. Normal stopping the engine. If the engine has been running at high RPM setting, the engine should be run at idle for a minimum of 3 minutes. That allows the cooling to uniform cooling the engine before shutdown. So before you take up to high power setting, you start the engine, let it set for about 2 minutes. Do your high power checks, good stuff. Once you've been at high power running, bring it back to idle and wait for at least 3 minutes if you're waiting to shut the engine down. Okay, it's pretty much standard for any engine, to be honest. Here's the start procedure. If abnormal conditions arise, the HP cock may be closed immediately, but if possible, the engine should be motored over to minimise thermal distortion immediately after shutdown. In other words, you've shut the engine down for emergency and then motor over to help get some cool air in there. But again, that depends on the situation. Has it been shut down because of a leak? Well, you don't want to be spinning the engine over, it's got a leak. Okay, so it does depend on what the emergency shutdown procedure was there for. Again, follow procedures, follow the maintenance manual, and any other procedures that might be appropriate to that aircraft. Okay. But once it's let cool down, you might do a dry crank just to see what was going on. Okay, so no ignition, no fuel. Operating limits. Yeah, you'll get used to some of the abbreviations. Also, what's one of the main ones we want to look at, which is right in front of you? What's one of the main limitations we're always watching on the cockpit gauges?
EGT.
EGT, yeah. Other types of abbreviation you might come across is TGT, turbine gas temperature, JPT, jet pipe temperature, TIT, turbine electric temperature, ITT, TOT, TET, but the usual one is EGT, exhaust gas temperature, one of the main limiting factors of your engine. Okay, so again, always keep an eye on it. You're checking it every few seconds because that can suddenly change very, very rapidly. Okay, so apart from normal limitations, we're going to look at things like flat rating and other parts, RPM, torque, thrust. You're constantly watching everything that is going on. Okay. And that's one of the most critical limitations, is that the temperature of the gas entering the NGVs, because that's one of the hottest part, apart from the combustion chamber itself, the next hottest part is your nozzle guide vanes. And again, depending on material, the hotter we can get the nozzle guide vanes, the hotter we can get the gas to the turbine, the more efficient, the more power we'll get. So again, if they get too hot, they can actually burn away. So again, there might be temperature settings there. Now always remember that the turbine is the shortest lived module. In other words, it's got the least amount of hours before it has to be taken out and replaced. It's going through the hardest scenario. Combustion cans, yeah, they're very hot. They're designed to take that heat. Turbines are taking the heat. They're going from very cold to very hot very quickly and then cooling down. They're getting the gas going through it, the back pressure. They're going through a lot of stress. Okay, so they are classed what's the shortest lived module. We tend to class sections of an engine as a module. A compressor would be a module. One of the engines I had worked on, the RB199, it had 16 modules. So you had your 3 compressors, your 3 turbines, your intermediate section, your combustion section, your exhaust section, your gearbox section, bypass sections, reverse thrust sections, and so they were all classed as modules. Okay, again, most engines are classed as modules as well. Okay. But normally, yeah, we're going to look at things like EGT as a main control factor. I've got an example of an over temperature inspection requirement to start. So say we get an over temperature. One of the factors, again, over temperature is how long was that over temp on for. Was it just a quick blip? Well, as it says here, we've got speed or time along the bottom, or the duration. So say you noticed an over temperature, say your limit was, what was it, 600 degrees, and you noticed it, but you brought the throttle down from 5 seconds. Well, 5 seconds, you're in here, 600 degrees, no action. 30 seconds, 600 degrees, no action. A minute, 2 minutes. So 200 minutes, at 600 degrees, this engine's okay. Doesn't matter the time there. So it's probably in the limit. However, if we've gone above 600 degrees, we're in this zone here. Okay, and it all depends on the time scale. So 10 seconds, we can go up to about 714 degrees. But as the time goes on, then we aren't likely to be in that high temperature range. So let's take an example. Let's say we had an over temp of 700 degrees at 15 seconds. But I call it 20 seconds, make it easy. So 20 seconds would be about there. 700 degrees is about there. So we're on the maximum. So we are in zone 1. Okay, so zone 1, it tells us visually inspect the LP turbine, and interior of the exhaust collector for damage. Determine and rectify cause of overtemperature. And obviously, the higher the temperature, the higher the potential damage. So let's say we had an extremely quick rise in EGT. It could be a hung start. So we've gone up to 800 degrees. No, we've gone in excess of 800 degrees. I would suggest if you've gone past 800 degrees, your engine is cooked. All right, so let's say we're in this zone 3. It says carry out procedure 1 as before. Also inspect combustion section and HP and LP turbines. If all is good and only one engine is affected, engine may continue in service for not more than 60 hours. So not very much. 60 hours, big commercial aircraft. That can maybe 4 or 5 flights maybe. To permit return to rework for base for strip and examination. For over temperature incidents exceeding the limits, reject the engine. So in other words, let's say we got 800 degrees and it was in there for 20 seconds. I would suggest that if your engine was 800 degrees for 20 seconds as an engine operator, you're not doing your job properly. Okay, you've not been watching the gauges. As I say, you're always watching the gauges. Pilots always watching the gauges. If they've got an overtemp for 2 minutes, something has seriously gone wrong. Yeah. Saying that, when they're flying, they could have severe conditions going on. They're having to deal with a lot of problems. They might be, more. Again, this will be recorded on the ADR because remember, temperature sensors go back to your accident data recorder. So in the event of an unfortunate crash or a failure, they can download. Hopefully not a crash, but can certainly download the information and get a precise amount of time, because sometimes information get from pilots, although they're very good, can be either exaggerated or not quite enough. They might say, I had an over temperature of the left-hand engine, and we say, okay, that's not a problem. How long was that over temp for? Oh, it was only 5 seconds, when actually it was maybe 50 seconds. Okay, so when you go inspect it in zone 1, well, there's more damage here, you can go and download the information. And likewise, they say, oh, it was 50 seconds. When actually it was only 5, because the pilots are dealing with a lot of things, especially in an emergency situation. Their heads are, they've got lots and lots to think about to try and, never mind, count how long that was in for. So most of the time it'll be a guesstimate, unless it's one simple fault. They've maybe noticed something. Oh, that's come on, the temperature's gone up, nothing else. There's no other indications apart from the gauge was going up, but everything else was indicating normal. It could just be a faulty gauge. It could be something simple. So don't go ripping engines out just because you've got over temp. Always follow what is in your book. Again, this is just an example of the type of thing you might find in a manual. Okay, so you get as much information as possible. Make sure you get fuel details. Look at the graphs, instructions, follow those instructions, and then determine where you are. Again, if you get a scenario it's in between, well, if it's in between, go for the worst scenario, because if it's in between, that's on the high limit of the lowest one. So I would personally go for the highest limit, and if M's okay there, then great, you've covered everything. Rather than potentially miss something here when it's borderline, always go to the next one up, just in case. Okay. And you'll be surprised that sometimes you check engines, a little bit damage at the front, that's fine, it's repairable, but then you check inside the engine and it's not repairable. Okay, so that might be repairable in here, but not repairable in here potentially. Okay, so again, always go to the next level up. If it's very close, to here, then fine, yeah, you check this one, but don't go to that one. Okay, so common sense prevails. Again, always in accordance with the instructions of the manual. And that's just a typical graph that might come across. And you've got a few more graphs in the book that give you examples of what you might come across as well. Okay. Okay. Engine limits, again, contain engine limits ones. RPM, well, you've got EGT, very crucial, don't want to overheat the engine. RPM, yeah, we don't want to overstress the centrifugal forces of the engine. Again, the turbine, apart from going the heat, the thrust, the air, going backwards and forwards, okay, the centrifugal force of that force trying to pull the blades off the disc. Remember I said a 2-ounce blade can have the effect of about 2 tons of pressure at the blade root itself. So the faster that's going, the more centrifugal force. What could that lend itself to? We go back to creep, primary, secondary, tertiary creep. So if you over rev an engine, you potentially bring that tertiary creep maybe closer to the secondary creep. Okay, so we have to check on limits on that. If it has been over revved for so, again, like EGT for too long, that might result in an engine change as well. Normally each spool will have a maximum 100% RPM, but they are allowed up to, remember, go back to FADEC 105% for N1, 105.5% N2 before it probably shut down. We do have the safety systems in there just in case. But again, things can go wrong, things can fail, and it all depends as well. And again, the over RPM, you've probably got an overheat scenario. Why is it going? Why is the spool going faster? Because maybe too much fuel, which means you've got high EGT as well. So you'll probably find the two are linked. You've got high EGT, you've probably got high RPM as well. Not always, but sometimes. And we'll look at a few other bits and pieces. Thrust limiting. Yeah, we need to make sure possibly have an engine operating at high thrust settings with high forward speed, so we get high ram effect, high pressure at the front means more fuel, so the pressure of an engine is going to build up. The pressure thrust at the back of the exhaust compared to the pressure at the front, we could get a scenario where we actually exceed the thrust limits. And especially high forward speed, low altitude, in a cold climate, so you've got nice and dry cold climate, that's going to be nice dry cool air, so high concentrated air, high thick air. So again, we could potentially have a scenario we could the mass of the compressor will cause damage to the engine. Reason that would happen, the pilots aren't flying to the envelopes of the aircraft design limits. And you tend to find usually more common military engines without thrust limiting. They don't have thrust limiting because sometimes we actually have to overstress the engine. They're designed to, especially in combat scenarios, just get out there as quick as possible. So we can put a switch in the cockpit, we can actually select it to more than what's designed to as an escape system. Fuel system is commonly linked to the compressor outlet, so your P3, causing the fuel flow to burners to reduce as the critical pressure is reached. So again, another safety environment where if it's sensing pressure, well, we've got too much fuel going in. Well, we're going to find that pressure from comparison of P1, P3. Okay, so P3 definitely, if the pressure's a lot there, it's starting to exceed the normal pressure, then we need to reduce the fuel accordingly. Torque limiting, just the same way as I do with thrust limiting, turboprop engines have to be torque limited, otherwise they overstress the crankshaft, the gearboxes, etc. An engine is producing too much torque, it will damage the turbine, the shaft, the reduction gearbox, the propeller shaft, and the propeller itself might indeed just go off. Okay, it'll just fly off. So engines will have a fuel metering system. We'll go back to module 17, where governors on the propeller control unit and that sort of thing, where it will limit it. Once it gets to a certain amount, the governor will kick in. We'll go overspeed condition, push the valve, depending on if it's single acting or double acting, and move the governor accordingly to decrease the output and slow the engine down. Okay. Right. Okay, right, that'll do for the moment. We'll come back to oil temperature after break. So let's go for a break at the moment. 10 past. Yeah, come back in about 20 minutes, guys. Okay, and we'll see you shortly.